Now we will use the merge procedure that we just defined to implement the merge sort. Okay, so to sort a input sequence is our ultimate goal. So the merge procedure we just defined is just a helper procedure. So now we will use the merge procedure as a subroutine to implement to our implementation for merge sort. So by subroutine, we mean that in the merge sort procedure, we will call the merge procedure as a function, as a predefined function. Okay, so actually the implementation is quite straightforward. It's quite neat. Okay, not a lot of code. So here's the merge sort we defined. It takes an input array A, the starting position P, the ending index R. Okay. So here we will do a if check at the beginning. We will check whether the P is strictly smaller than R. So this is important. Because given a segment of an array, the starting index could equal the ending index. That means there's 0 elements in it. And we will only execute the code here if there's more than one element. There's more than, okay, I need to fix what I have said before. So when the starting index and the ending index PR, they have equal values, that means there is only one element in it. So in that case, we don't need to sort anything because there's just one element. And we only need to execute the code in the case that there are more than one element. Okay. So what this function does is to sort the elements in the sub-array indicated by the index P and R. Okay. And the line 1 checks whether there's one element or not. Okay. So if the two indices they are equal, then the procedure will do nothing. And otherwise, the code will divide the sequence into 2 sub-arrays. Okay. Remember the word divide, right? This is a divide and conquer algorithm. So the first step is to divide the original problem into 2 subproblems. In our case, we need to divide the array into 2 sub-arrays. Okay, and we divide the array by computing the midpoints Q, which is somewhere near the middle of it. We use the floor symbol, right? Because all these are integers. Q also need to be an integer number. So we have 2 sub-arrays. The first one is from P to Q, and the second one is from Q plus 1 to R. These are how we get the subproblems. Okay, the next step is to solve the subproblems, right? So this here is where the recursion happens. We call the merge sort itself, okay? Within the definition of the function, we call the merge sort itself. Call the merge sorts on each of the sub-arrays. Okay, we have 2 sub-arrays. We first call merge sort on the first sub-array. Okay, here the starting index doesn't change, but the ending index becomes the midpoints. Okay, and the second call of merge sort applies to the second sub-array, in which the starting index changes from P to Q plus 1, and the ending doesn't change. Okay, so we recursively call the merge sort on the 2 sub-arrays. And lastly, which is our third step, we call the merge procedure after or after the two sub-problems, after the two sub-areas are sorted. Okay, we need to merge it. Okay, so the merge is for the combine step. Okay, divide and conquer, and after we conquer the sub-problems, we need to combine all the solutions. So we given a input that we know the size, which we know the size of, then we can simply sort the whole sequence on the whole array by calling like A with 1 as the input sequence, as a starting index, and the A dot length, which is n, as the ending index. Okay. So because the function, the procedure merge sort itself will be recursively called, so the indices, the starting indices and the ending indices need to be carefully considered. Okay, it is not necessarily 1 over n. We need to take arbitrary values for starting and ending indices so that these functions can be called right here. Okay. All right. So that's the implementation of the merge sort. So in the next video, we will gonna see, you also use a simple example to see how the merge sorts do the sortings on actual examples, and we visualize the especially visualize the processes of how the recursive calls are handled.